Solving two-step equations. When we're solving equations, it's kind of like wrapping a present. We gather all of our items, and I'm going to put the present in the box, close the box, and wrap it up. To present, I need to do the opposite. I need to start with taking the wrapping paper off, opening up the box, and then taking my item out, which is the opposite way that I did the wrapping. When I'm solving equations, I'm using this idea of my order of operations, but I'm going to start at the end, and I'm going to start with addition and subtraction, and then move to multiplication and division, exponent and radicals, and the last thing I would do is parentheses. And then if there's anything inside of those parentheses, I'd start the process over back with that addition and the subtraction. The ones that we're going to work with today are definitely simpler than that. My first step is to look at my goal. My goal is to get x all by itself. So in this particular equation, I want to get this x by itself, and it's tied to the 4 through multiplication, and then it's added to 13. Since if I started with the x, I'd multiply first and then add 13. 13 is the last thing I do, so I'm going to get rid of that by doing the opposite. For many people, it's easier if you draw a line down the equal sign, and if that's easier for you, go ahead and do that. If it's not necessary. Then I want to look at this plus 13. And the opposite of plus 13 is minus 13. So I'm going to subtract 13 to get rid of it. Whatever I do to one side of the equation, I must do to the other side of the equation. The 4x I didn't touch, so I'm going to put that 4x down there right away. 21 minus 13 is 8. And then I'll have my equal sign. So now I have 4x equals 8. To get the x all by itself, I need to do the opposite. And as I said before, the 4 is multiplied by x. So to undo that, I divide by 4. So these 4's will cancel, leaving me with just x, because 4 divided by 4 is 1. And then 8 divided by 4 is 2. X is all by itself, so I'm done. X equals 2. On the next equation, again, I'm just going to draw my line down the equal sign. That's optional for you. I want to start by getting rid of this 8, because if I get x by itself, whatever's in front of x, that's the last thing that I do. And to get rid of this 8, when it's out front, it's really a positive 8. We just don't write the plus sign, because that would be a lot of extra work. And mathematicians typically are pretty lazy. We don't want to write those extra signs in there. So I'm going to start with subtracting an 8. This is a very common mistake. Remember that number out front, if there's no sign on it, it's a plus. So to get rid of it, I'm going to subtract it. 8 minus 8 is 0. I'm not going to write that 0 down. I don't want to add all that extra clutter. This minus sign from that negative 2x, just from right here, just gets written right down there. And then I'm going to put my 2x. 30 minus 8 is 22. And then I'm going to divide both sides by the same number. And I divide by whatever's in front of x. And in this case, that's a negative 2. The negative 2's cancel, leaving me just the 1x, or x, because negative 2 divided by negative 2 is 1. So x is equal to 22 divided by negative 2, which is negative 11. And that's my answer in the end, because x is all by itself. A couple more examples to go through. Same idea, drawing your line or not drawing your line, just keeping things pretty much lined up. Opposite of plus 2 is a minus 2. And I haven't done anything with my x, so that's just going to be a negative x. 17 minus 2 is 15. I'm not done because x isn't by itself. This negative here still we need to get rid of that. And this negative is really like a negative 1, and if you want to, you can just add in that negative 1. So I'm going to divide by negative 1, and that x would equal negative 15 when I'm all done. And I could always go ahead and try it and plug this back up into my equation to see if it works. Negative 15 times that negative 1 would give me a positive 15. Add 2 more gives me 17. So whatever I get for x, it should work when I plug it back up into the equation. Looking at the next one, I'm going to start with that negative 5 out front, and I'm going to add 5 to both sides. I'm going to do this one without drawing in the line so you can still kind of see how that would work. That plus 3 I didn't touch, so I'm going to put it as a 3x. If you want to put that plus out front, that is just fine. 26 plus 5 is going to give me 31. And then I'm going to divide both sides of my equation by that 3. And so x is going to equal 10.3 10.3 repeating. And again, if I plug that back up into my equation, it would work out. Make sure if you plug in that 10.3 repeating that you're going to put lots of 3's in there when you multiply that by the 3. Otherwise, with that rounding, it's going to give you some sort of a mistake. In our last example here, we have a fraction, that 4 divided by x. And we're still going to start with getting rid of that adding or subtracting first. So I'm going to take care of this minus 2. And I'm going to add 2 to both sides. I haven't touched the 4 divided by x, so that's going to stay the same. And in this case, 10 plus 2 is 12. Now this is the part that gets confusing for some people. We're going to get rid of whatever's in the bottom of that fraction, and we're going to get rid of that by multiplying. So I'm going to multiply both sides of my equation by an x. And when I do that, x divided by x, that's still my 1. So I have 4 equals 12x. And then what I'm going to do is, I'm still not done because x isn't by itself. I need to divide by 12. And so in this case, 1/3 or 0.3 repeating would equal